You type a website address, click Enter, and within milliseconds your device sends traffic toward the internet. But before that traffic gets anywhere, a firewall may ask several critical questions. Where did this packet come from? Where is it going? Is it part of an existing conversation? Does a security policy allow it? And does it look suspicious? In this video, we will break down what a firewall actually does using packets, sessions, policies, and a practical example. Many people think a firewall is simply a device that blocks bad traffic and allows good traffic. That is directionally correct, but it is far too simple to explain how modern enterprise firewalls make decisions. A firewall is not just looking at a single packet in isolation. In many environments, it tracks sessions, compares traffic against policies, performs network address translation, creates logs, and may apply additional inspection controls. Understanding this process is essential for configuration, troubleshooting, and secure network design. By the end of this video, you will understand the difference between a packet and a session, how firewall policies are matched, why rule order matters, and how to troubleshoot the most common question in firewall administration. Why is this traffic not working? At its core, a firewall is a security control that enforces rules for network traffic moving between different security zones. For example, traffic may move from an internal user network to the internet, from the internet to a public web server, or between separate internal network segments. The firewall provides three fundamental functions: visibility, control, and enforcement. It helps you see traffic. It lets you define what traffic should be allowed, and it blocks traffic that does not meet your policy or security requirements. In enterprise environments, firewalls are often placed at the network perimeter, between VLANs, in data centers, in cloud environments, and at branch locations. Let's begin with the packet. A packet is a small unit of data sent across a network. When you open a website, send an email, connect to a VPN, or access a cloud application, your device sends and receives packets. A packet contains useful information that a firewall can evaluate. This commonly includes the source IP address, destination IP address, protocol, source port, destination port, interface, and direction of travel. For example, your laptop may use the private IP address 192.168.10.25. It may connect to a web server using TCP port 443, which is commonly used for HTTPS. The firewall can inspect these attributes and decide whether this traffic should be permitted, denied, translated, logged, or inspected further. But a modern firewall usually does not make every decision based only on a single packet. Most enterprise firewalls are stateful. This means they can track the state of a connection over time. Instead of treating every packet as unrelated, the firewall can recognize that several packets belong to the same network conversation. That conversation is called a session. A session represents an active communication flow between two endpoints. Consider a user opening a secure website. The user's device initiates a TCP connection to the web server. The firewall sees the initial traffic, evaluates it against the relevant policy, and, if allowed, creates a session entry. That session entry can include information such as the source and destination addresses, ports, protocol, interface information, security policy that matched, and the current state of the connection. Once the session exists, return traffic from the web server can usually be recognized as part of that same approved connection. This is one of the most important benefits of a stateful firewall. You do not normally need a separate policy allowing every response packet from the internet back to the internal user. The firewall knows that the return traffic belongs to an existing session that was initiated and permitted from the trusted side. Stateful inspection helps a firewall distinguish between expected return traffic and an unsolicited connection attempt. If an internal user visits a website, response traffic from that website may be valid because it belongs to an existing session. But if an unknown host on the internet suddenly tries to initiate a new connection toward an internal device, there is no matching session, unless you have explicitly published a service and created a policy to allow it. That traffic should be blocked. This is a foundational security principle: allow what is needed and deny what is not explicitly required. A firewall policy is a rule that tells the firewall how to handle matching traffic. A policy may evaluate several criteria. Common examples include source zone, destination zone, source address, destination address, user identity, application, service or port, time schedule, and security profile requirements. Let's use a simple example. You may have a policy that allows users in the internal network to access web services on the internet. That policy could permit DNS and HTTPS traffic from the user network to the internet zone. You may also have a policy that blocks users from reaching sensitive server networks unless they have a legitimate business reason. The key idea is simple. The firewall compares traffic against policy criteria, finds the appropriate matching rule, and then applies the configured action. In many firewall platforms, policy order matters. The firewall evaluates rules in sequence, and traffic may match the first applicable policy. This means a broad rule placed above a more specific rule can cause unexpected behavior. For example, if you place a broad allow rule above a more restrictive rule, traffic may be permitted before the firewall ever reaches the intended restriction. Good policy design places specific rules before broader rules and avoids unnecessary, overly permissive access. A policy such as any source, any destination allow may solve a short-term connectivity problem, but it can create a long-term security problem. Let's follow a realistic example from start to finish. A user on the internal network wants to open a secure website. The user's laptop has the address 192.168.10.25. First, the device may need to resolve the website name using DNS. The firewall evaluates the DNS traffic against the applicable policy. If DNS is allowed, the request is sent to the approved DNS server, and the response returns through the matching session. Next, the user's browser initiates an HTTPS connection to the website using TCP port 443. The traffic reaches the firewall from the internal user's zone. The firewall checks the route, identifies the destination zone, and evaluates the traffic against its security policies. If the traffic matches an allow policy, the firewall may also apply source network address translation, commonly called source NAT, so that the internal private address can communicate through a public address on the internet. The firewall then creates a session for this connection. When the web server responds, the firewall checks whether the return traffic belongs to that existing session. If it does, the response is translated back as necessary and delivered to the internal user. From the user's perspective, the website simply loads, but behind the scenes, routing, policy matching, session tracking, NAT, and logging may all be taking place. Now let's look at the opposite case. Imagine the user attempts to access a destination that is not allowed by policy. The firewall receives the traffic, evaluates the route and policy criteria, but it does not find an applicable allow rule. Depending on the firewall design and configuration, the traffic may be denied by an explicit deny policy or by an implicit deny rule. This is why firewall logs are so valuable. Logs can reveal the source, destination, service, action, matching rule, interface, timestamp, and sometimes the reason the traffic was blocked. When troubleshooting, do not guess. Start by checking the logs and confirming what the firewall actually decided. Although exact packet processing behavior varies between firewall vendors and configurations, this is a useful high-level decision model. First, traffic arrives at the firewall. The firewall checks whether the traffic belongs to an existing session. If it does, the firewall can process it as part of that established conversation. If it is a new connection, the firewall performs the required forwarding and policy checks. It determines where the traffic should go, whether a policy allows it, whether translation is required, and whether security inspection profiles should be applied. The firewall then allows or denies the traffic and generates logs according to the configured logging policy. Remember, this is a conceptual model. Always consult the relevant vendor documentation for exact behavior on a specific platform and software version. Here are 5 common firewall troubleshooting mistakes. First, assuming every problem is a firewall policy problem. Routing, DNS, NAT, interface status, asymmetric paths, and server-side configuration can also cause connectivity failures. Second, ignoring route lookup. A correct policy does not help if the firewall does not know how to reach the destination. Third, forgetting NAT. Traffic may be permitted by policy, but still fail because the expected source or destination translation is missing or incorrect. Fourth, checking the wrong policy. Always identify the actual source zone, destination zone, address, application or service, and direction of the traffic. Fifth, not checking logs and sessions. Logs show the firewall decision. Session information can show whether a connection was created, how it was translated, and whether return traffic is being seen. The most effective troubleshooting process is systematic. Validate the path, validate the policy, validate NAT, inspect the session, and confirm the logs. To build a more secure firewall policy set, follow a few practical principles. Apply least privilege. Allow only the users, systems, destinations, services, and applications that are actually required. Put specific policies before broad policies. Enable useful logging for important allow and deny events, especially for sensitive networks and internet-facing services. Regularly review rules that are no longer used, overly broad, temporary, or poorly documented. Segment networks so that a compromise in one area does not automatically provide access to every other system. Test changes in a lab or controlled maintenance window whenever possible. And keep firewall software, signatures, and security policies updated according to your organization's change management and risk processes. Let's summarize. A firewall evaluates network traffic to enforce security and connectivity policies. Packets contain the information needed for the firewall to understand the traffic. Sessions allow a stateful firewall to track active conversations and safely permit expected return traffic. Policies define what traffic is allowed or denied. And logs provide the evidence you need to understand what the firewall actually did. Once you understand packets, sessions, policies, NAT, and logs, firewall troubleshooting becomes much more predictable. If this video helped clarify how firewalls make decisions, subscribe to Firewall Support Center for practical network security, firewall configuration, troubleshooting, and enterprise networking labs. Next, watch our video on NAT on firewalls, where we explain source NAT, destination NAT, and why NAT rules often cause confusing connectivity problems.